Okay, so here's what I'm going to share my screen first. Here's what we're going to cover for today. Okay, first one, we're going to do a little bit of review on section 1.1. That's what concept summary, a review for the 1.1 key feature of a function. First one, let's look at what's a function. A function is a rule that assigns each x to a unique y. Okay. The function we're going to use notation y equals fx or y equals gx. That's the first part. Function, it's a rule that assigns each x to a unique y. Okay, I draw a diagram here. Look at here. For each number, you assign one y. For each number, you assign one y. For each number, you assign only one y. Okay, 2, you assign 11. 3, you assign, okay, 21. So that's a function because for each x, you only can assign one y. Even that y have 2x, that's fine because we said that only one x, where each x assign a unique y. So that one is fine. This x assigned to this y. This x also assigned to this y. But for each x, you only assign one y. So that's a function. That's a function. Okay. Function is a rule. Assign each x to a unique y. Look at like this diagram. For each x, you only assign one y. So that's what we got. Okay. Okay. Besides the definition of function, okay, we can go. We also we'll look at a domain and a range. Let's go back to this part. Section 1. Let's look at a summary here. What the book says. There's a concept of a summary. You can look at that by yourself in the future. Okay. Function is rule assign 1x to each unique y. Okay, look at here. This function for each x, you can only find one y. For each x, you can only find one y. Okay, one y. So those are examples of function. For each function, okay, there's two concepts. One is the domain. Domain is all possible x. Look at this example. What's a possible x? X can be go negative. Okay, until negative infinity, can go this side, okay, to positive infinity. So x can be any number. So that's the domain will be negative infinity to positive infinity. Okay, what's the range? Range is related to y. Related to y. Okay, look at here, y cannot be negative number. Any positive number or 0 be fine. So that's why range is 0 to positive infinity. 0 included. That's the domain. That's the domain. What's the intercept? Intercept, look at here. X-intercept, Y-intercept are all 0. All 0. Because, okay, at here you cross the x-axis. Okay, at here you cross y-axis. That's the intercept. Okay, for that one, there's no x-intercept because never cross x-axis. Y-intercept going to be 1. So that's okay. Domain and range and intercept. Also, you see, here's a north point. Here's a north point. This is called vertex. Vertex. If you have a graph like that, okay, the highest point could be vertex as well. Okay. Also, we talk about increasing, decreasing. Did we talk about it? Yes. Okay. This part is decreasing, getting smaller and smaller, go down. This part increasing, go up. So that's a summary. Okay, and a review what we learned about function. First one, you need to understand the definition, like this one, definition. Okay, and the diagram. Then we talk about the domain, range, okay, increasing, decreasing, and x-intercept, y-intercept. That's all we learned so far. Okay, so far. Any question? If you don't have a question, we're gonna cover new stuff. That's what we're gonna cover for today. Okay, we're gonna talk about talk about a graph transformation. What do we mean? Talk about transformation. Basically, we talk about a shape, a graph can move, okay, from one place to another place. So let's go to the grammar first. Okay, we want first grammar. Okay, we talk about a translation of function. I have two functions. Okay, two functions. Okay, one function is y fx equals x squared. One function is gx equals x squared minus 1. So let's compare those graph first. Let me compare those graph. Oh, I need to get this one. Did I get this one? I'm gonna move that one. Okay. Okay, we're gonna go draw a graph here. 1 fx equals what? 1 fx equals x squared. So y equals x squared. That's a graph. Another one. Okay, y equals x squared minus 1. Wrong. This is equal. Look at those two graphs. What do you can tell me? Okay, compare those two graphs. What do you can tell me? You see this graph. How can we get this graph? Basically, you move the red one down one. Move the red one down one, right? You're gonna get the graph. Move the red one down one by 1 unit. Move red one down by 1 unit. You got blue one. Okay, how about this one? Y equals x plus 2 square minus 1. We got a green one. Compare the first one. Okay, compare the second one with third one. Compare those two. What you can tell? How you can get the last graph? Look at here, from here to here, what you did? You move to left by 2 units, you got a green one. Let's look at the 3 curve again. Compare the first one, second one, you move down, you got a second graph. Okay, last one, what you did? Compare second one with, last one, you move to the left by 2 units, you got this one. You got this one. So that's how you got the graph. Okay, now, let's check what do we get here. You see, we want you to graph. Okay, I'm gonna make this visible to you guys. So look at the difference. Look at it here. This is y equal, first one is fx equals x squared. Second one is gx equals x squared minus 1. So basically, what's the relation between gx and fx? Gx equals fx minus 1. Gx equals fx minus 1. So graph-wise, the graph moved down by 1 unit. You got the blue one. Okay, what's the second one? Second one, what happened? You replace x by x plus 2. So you got a x plus 2 squared. And also you need to subtract 1. So the hx going to be equals fx plus 2 minus 1. So what happened? The graph going to move down by 1 unit. and move to the left by 2. Look at the graph. So that's the translation we have. Okay. So every time you subtract 1, you move down. Okay, you add a 2 inside, you move to the left. Okay, by 1 unit, by 2 units, Are we clear on that part? You see, red subtract 1 is outside, so you move down. Red plus 2 is inside. Okay, you're gonna move to the left. If red one is subtract 2, what happened? If this one subtract 2, what happened? I'm gonna copy paste so you guys know what I was talking about. Your function, say, AOX equals -2. -2 plus 1. If equals this one, what's going to happen? The graph, what's going to happen to the graph? Tell me what's going to happen to the graph. You see, plus 2, say it again.
Graph moved up by 1 and moved to right by 2.
Great, Ray is great. Okay, that's correct. Okay, in that case, the graph going to be, right down here. Ray is correct. The graph going to move up by 1. By 1 and move to the right by 2. Very good. Okay, really understand well. Good. Okay. Okay. So, is there any question at this moment for the first example? Okay, if you don't have problem, let's compare. Okay, rules. Okay, second part. We want you to compare. Okay, fx equals x squared and gx equals -x squared. Okay, let's see what happened here. So 1 is equals x squared. We already have that one. 1 is equals what? Equals -x squared. So what you can tell by this graph? 1 is positive x squared, 1 is -x squared. Flip over, right? Okay, you flip that one over, you're gonna get the graph. So basically it's a reflection. That one is a reflection of original graph. So I'm gonna highlight this one here. Okay, what happened is that one, okay, gx is equals -x. Okay, the result graph-wise, okay, the graph is reflected across the x-axis. Flip over, you got the graph. Okay, you got a graph. Okay, any questions so far? Now, how about the root 2 function? What happened? Let's draw a graph first. Okay, we're gonna draw a graph here. Okay, y equals, okay, 2x minus 3 and y equals, okay, 2 -x minus 3. So that's a graph. What you can tell me about the 2 graph? Difference is replace x by -x. Replace x by -x. And look at the graph, what happened? Flex across which axis?
Y.
Very good. Who said that? Who's talking?
Kia.
Kia. Okay, great. Kia. Good. Good work. You see the graph, original graph. Okay, you replace x by -x. Okay, the curve going to be flip over. across y-axis. So that's what we're going to say here. Okay. Why not this one? Okay, you see in this case, you replace, okay, gx equals this one. I can write down this one in better way so you can see that better. That one is same as, okay, 2, okay, multiply negative x. Basically, you replace the x by negative x, the result is going to be, the graph going to be, okay, reflect across y-axis, like we said here. So in the future, if the negative is outside, you flip over across the x-axis. If the negative is inside, you flip over across y-axis. That's the difference between them. Okay, any question? We talk about those translations. Okay, translation. You see, this one inside add some number or add some number outside. This one is move up and down or left to the right. Okay, this one is move this part. First, you can move up and down or right and left. If you have negative outside, flip over across x-axis. If you have a negative number, negative sign inside, flip over across y-axis. So that's the two examples we talk about. Any questions so far? If you don't have a question, we're gonna move on. Okay, look at this one. Okay, we want you to draw a graph. Okay, fx equals absolute value x, and also okay, gx equals 2, okay, absolute value of x on the domain of that one. So let's look at a graph as well. We're gonna go back to the book, look at the graph. Okay, go back to the book, look at the graph. Oh, we need to go one step back, one more step back. 1.2, section 1.2. We're going to talk about okay, this example. So that's a two function. We need to look at a graph. You see, we need a graph fx equals okay, absolute value of x, and graph okay, gx equals 2fx, which is 2 absolute value of x. So what on the domain of that one? What's the graph going to look like? We're going to check the graph. You see, for a -1 to positive graph, this one is a gx, this one is a fx. What you can tell me? Look at the graph, what happened? This is the original graph, now what happened? This is the original graph, now you pull it up, right? This one is fixed at the 0, is fixed, and you pull it, okay? So basically you stretch it twice, okay? Original is blue one. Now how you get the red one? You stretch it, okay? You stretch it, you pull it up, pull it up, pull it up. We call stretch it. Stretch it by how much? By twice, okay? By twice. Or you can say stretch it by a factor of 2. Stretch it by okay, a factor of 2 because the original is here, original is like that one. Okay, multiply to everything, okay, pull up by twice. So that's what we got the graph. So that's okay, first one. So if you gx equals the original function multiply 2 outside, you're going to stretch it by a factor of 2. Okay, twice, the graph become twice higher. Are we clear on that one? Okay, that's the first one. We're going to highlight that one here. What we did is that one, okay. If gx equals 2fx, the graph going to stretch twice vertically. Okay, twice vertically. Pull up. Or you can say, okay, stretched by the factor 2, Okay, either way is fine. Stretch vertically, twice vertically. So that's what we get. Okay, that's the first one. Now let's look at the second one. Compare the graph this one and this one. Let's see what happens. We're gonna graph that one. Use our tool. Okay, one is x squared, right? We like x squared because x squared is easy for us to demonstrate something. Another one is y equals 2x squared. I did too much things here. Let me. So what happened in this case? Original is red one, new one is blue one. What happened? Tell me. You push them together, right? Push them together. We call compress. Compress about how much? You see, compress original here is 1, right? You compress become 0.5. Original here is 2. You see, this one is related to 2. Here is related to 1. You compress halfway. So in that case, what happened? You compress it horizontally by factor of 2. Are we clear? You compress it horizontally by 2. So I'm gonna highlight this one. Okay. Look at here, what's the difference between them? If the number multiply outside, you're going to stretch it vertically. This stretch is become larger, become higher. If the factor is multiplied outside, if the factor is multiplied inside, opposite, you push them together horizontally, become half smaller. So that's the difference between them. Any questions? If you don't have question, let's see what we talk about. If the add or subtract something is move up and down on the left and right. If you change the sign, depending on sign is inside or outside. If the outside, flip over cross the x-axis. If the negative sign is inside, flip over cross y-axis. Third example, we talk about multiply number. Multiply number outside gonna be pull up, make it larger vertically. If the number inside, even the number still number 2, but becomes smaller, you compress the halfway. So that's what we get. Now we're gonna ask you guys to do 2 exercises. Let's look at the 2 exercises here. Let's look at an example. Okay, look at here, the original graph is y equals fx. The graph represents y equals fx. You see, f here represents fx. Using this graph, how can you graph the combination of transformation? This is a graph of fx. Can you graph y equals negative fx plus 2? Think about that one. Tell me how you can graph that one. Mayuka, you have an answer for me?
So you first needs to flip by y-axis.
By y-axis? You see, that's negative. If it's here, your negative got here, right? Ray, what do you say? What is your suggestion? Ray, I see you raise your hand.
Move the graph twice to the left. Yeah, left.
What do you mean twice? Move 2 steps or twice? Move 2 steps, right?
2 step, 2 step.
And move 2 steps to which direction?
Left.
Left, very good. Go that side, good. Okay,
And
and
then
it's the first step.
reflected across the X.
Very good. Raise crab. First one, move to the left by 2 steps, and then flip over, cross the x-axis. Look at here, here's the solution. Okay, your original graph is fx. Now first step become, okay, fx plus 2. That one going to be, okay, move to translation of fx. Left to unit, move to the left side to unit. That's what we got. The dash green, okay, curve, green lines. Okay, now you put the negative in front of it. What happened? You flip cross x-axis. Okay, so that's how you got the graph. Ray is perfect on this question. Good. Are we clear on how to draw a graph? Use, okay, use a transformation. Okay, we're gonna move on. Okay, let's see what's the next example we're gonna show. Next example, we're gonna show, okay, example 5. Let's check. Example 5, go back. Example 5. Where's my example 5? Oh, here you go. Okay, this fx, y equals x squared. Okay, result the graph of gx equals this one. What do we get? What is the transformation, okay, of fx result going to produce a graph of gx? What the transformation you're gonna get? You're gonna what the transformation result will produce? Okay, this red, okay, curve. Tell me how. Okay, Mayuka, you have answer for us, right?
Yes. So you first flip.
Okay. First
flip by-
flip over, right? Good, good. Flip
And then-
over, cross which axis?
X-axis.
Very good. And
And
then
afterward, you horizontally stretches.
very good.
Good.
I like that. What Marika said is first one, okay, because there's a negative sign here, you flip over across axis. Okay, after you flip over, you got a graph like that, but not okay, wide enough. What happened? You stretch it by factor of 3. Okay, you will get this, okay, graph. So let's see the solution. Okay, this one represents horizontal stretch. Oh, okay. Book have different step. Book trying to stretch it first. That's okay. That's okay. We'll produce the same result as Mayuka mentioned. Okay, so book stretch it, okay, by factor 3 first. What's the next step? Next step, because negative. Okay, what happened? Reflection cross x-axis. Okay, so result give me the same. Okay, the order is different. You can flip over first, then stretch it, or you stretch it, then flip over. Okay, any questions? Okay, if you don't have question, means you guys understand, right? So let's see what we talk about today. You see, we talk about a horizontal move or vertical move. Then we talk about a flip over cross x-axis or y-axis. Okay, then we talk about a stretch or compress vertically or horizontally. Then you did a 2 exercise. Some of you able to give us the correct answer. Okay, now let's see the summary for our class. Okay, let's see the summary here. Concept summary. You see that one, talk about a horizontal, okay, horizontal move, subtract the x, change to x, subtract 2, you move to right by 2 units. You add some number, you move up. That's what we talk about. Okay, let's talk about a horizontal move or vertical move. Okay, vertical move, add something inside or outside. Okay, next one, add a negative sign in front of outside. You're going to flip over cross x-axis. If you add some sign, negative sign inside, you're going to flip over cross y-axis. Okay, then next part we talk about put the number inside. Okay, that one you're going to stretch it like a Nazi grammar. 1/3, this is 1/2. You're going to stretch it horizontally by factor of 2. Okay, by over 2. If the number is outside, what happens? You're going to stretch it horizontally by factor of 2. That's all we cover today. Later on, you can look at your textbook, okay, about rule summary to remember them. Okay, will help you to identify which transaction you needed. Okay, are you understanding well? Okay, looks like you understand well. Good. Okay, here's a homework. Okay, homework is the second set. You guys already know it. And there's 3 students already completed. So that's a homework. Okay, section 1, 2 homework. Okay, homework. Okay, completed that done by Monday, by your time, Japan time Monday. There's a due date over there. Okay. Any questions so far? If you don't have a question, that's all we're able to cover for today. You guys have a good weekend and enjoy your homework and please complete it. Okay, complete it. Okay, that's all for now. I'm gonna stop sharing. Okay. Okay, bye now. Okay, if you have questions later on, you can always text or not text me, email me. Okay.
Okay.
Thank
Good
you.
night.
Thank you.
Thank
Okay,
you.
you're welcome. You're welcome.
Have a nice weekend.
You too. Thank you.
Wait. I have a question.
Okay, what's the question?
I don't know your email, so please teach me your email.
Oh, give me your email. I'm going to type in here. Okay, email. So that way you won't kiss. That's my
Okay.
email.
And
ycao@ko.edu.
thank you. And is it
You're
okay
welcome.
to to ask question by this email?
Okay, yeah, you can send me email by send me email if you have any question.
Okay, thank you.
You're very welcome.
See you.
See you.